Everyone out there, today we're going to be doing references in C++. So what are references? We're going to start by using and including our handy IOStream header file, and then after that including our namespace standard and then integer main, and then after that our container where we put the return 0. Okay, so what are references? References are basically some kind of alias to another object, like a secondary name. For instance, if I have an integer, say something like num10, okay, and then when I do console output num, you're gonna see that, let me save this up, code 48. When I'm gonna execute this code, you're gonna see that there's just 10 out on the console screen, but I can't create a secondary variable to it that associates to it. There's no way, but there is in C++, and that's called referencing, and that was a major concern when C++ was out. So how do we create these kind of references? We create a new variable. It's called a reference variable, and it uses this ampersand symbol in the front. So you have ampersand, and I'm gonna say num1, and then it will reference to num. So basically I say num over here. So what I basically said is that this new ampersand num1 is gonna reference to the num variable. So whatever value is stored in num will be stored in num1. And now I could say if I console output num1, and let me put an end line over here, and let me put an end line over here too. So whatever is gonna be stored in num is gonna be stored in num1. So execute, compile, and run. And there you see 10, 10. And even if I change one value of num1 or the num2, it's going to be changed in both of the variables. So for instance, if I say somewhere over here in the code and I say num1 is equal to 1000, and if I save this and then I execute the code, compile and run, so you can see that 1000 is changed in both of the variables, the referencing variable and the original. So that was with referencing variables, which are called aliases to other variables, the secondary name. So you guys might be wondering, why do we even use references? So basically references don't use any kind of memory. They're basically aliases, like we've already mentioned, of the same exact original variable. They just appear as an alias and they are exactly the same. Just imagine a variable having two names. So we could use this in a number of occasions, and one of the most famous occasions is that when we want to pass by reference and pass by value. So in this code, I'm going to create a function called swap. So we're going to have a void swap function, and it's going to have two values. So we're going to have integer a and integer b, and then after that you're going to see something out. So basically what's going to happen is that we're going to swap the two numbers. So suppose we have a number 1 and we have a number 2. Make these values better, and now I'm going to make one parameter over here called temp. Not parameter. These are two parameters, input parameters, in num1 and num2. And inside the function, I created a temporary variable called int temp, and I assigned it to the value num1. So why did I even basically do this? I want to switch the value of num1 with num2, and the num2 having value num1. So that is not possible by just explicitly saying something like num1 is equal to num2, and then after that we say num2 num2 is equal to num1. So this is not right, because over here when you're saying num2 assigning to num1, basically whenever num2 is assigned to num1, okay, the first part is okay, but when it's num1 assigning to num2 over here, there's going to be something, a problem is going to appear. You could try this out by yourself. There's going to be a problem. So for that case, we use a temporary variable called num1. So what's going to happen is that we're going to say temporary variable is equal to num1. Now we say num1 is equal to num2, but now for num2 we're not going to say it to num1 because num1 is already num2. So for that we say num2 is equal to temporary, which was already associated to num1. So that's how both are going to get swapped. And inside the main function I'm going to create two numbers. So basically I could say int a is equal to 100, and then I say int b is equal to 200, and I want to swap the value of 1 and 2. So what I could say is that I use the swap function, and I say my value a and b. I just put, these are my arguments, and then after that I cancel out and I say a is something like that. We'll say a is, and then we put the value of a, and then console output, and then I say b is, and then after that we put the value of b. Okay, now the thing is, now you're gonna see that when I put the swap function, and for me, I'm supposed to see that when I put these arguments inside, these arguments will go transferring to this function. And now there's some parameters, input parameters already created in here. So extra memory is created. And what the thing is, the purpose is that this is going to get swapped. So basically these two parameters, input parameters, these are basically called imaginary, and they're not the real. So this is called pass by value. This is called pass by value. So by passing by value, we're not basically using our same exact values which we called in our argument. We are using a different imaginary kind of parameter inside over here, which has nothing to do afterwards, and it won't even change our values to 100 and 200. So this code won't work. It's just gonna work for these two parameters which are inside of the function, and when it's out, a and b will remain the same. So when I save this code and I execute this out, compile and run, you're gonna see a is 100 and b is 200 as expected. But I wanted to switch them because I created this function. So for that reason, we pass by reference, and that our handy reference variable, which is called ampersand, will be used over here after the data type. And conventionally, it's used represented right after right before, meaning preceding the identifier. So I proceeded. Now what's basically doing is now it's passing by reference. So this is swap AB. So swap AB will be transferred over here, the values, and these ampersand shows that nothing is new created. The same exact values are being restored over here, and they're going to be swapped, and then when it's returned, it's going to affect the same kind of values. So basically they're going to get switched out. And when I execute and compile and run to prove you guys, you're going to see now it's switched. So by passing by reference, you are making the performance of the computer better by not using that much variables. You're not declaring that much, and you're also modifying your argument input arguments. So that's the benefit of using references. One thing I wanted to point out over here is that we could use constant data type. So basically another type of keyword is called constant. So for explanation purposes, I'm going to create another data type called integer. Constant is, then after that I'm going to call it pi, and is equal to something, for that we need a double. So we'll say double constant pi, and we'll have 3.14. Now what is the purpose of a constant? So when we include this const, this means that now this is no longer a variable, because a variable's definition lies with the fact that it will change throughout the code, and the constant won't change. So meaning it is staying that exact value. Even if you try to modify it, it's gonna throw you an error. So execute, compile and run. It is 3.14, and even if I try to change it, it's gonna throw me an error. So if I say pi is equal to 4.33 and I save it and try to execute, it's not even gonna allow me to execute it because it's saying assignment of read-only variable pi. Okay, so that was it with constants. Just wanted to bring it up, and you could include it with any kind of data type. You could include it with integers, you could include it with doubles or floats, whatever you want. One more thing is that constants are also used in referencing when we call it by pass by reference operator. So remember when we had the reference operator, for instance, we had a number like, if I have a triple function and I need an integer inside, and I could say integer constant, and then I address it to the address, and then I. So for this case, it's gonna remain the same throughout the code no matter what, and it's not gonna create another data type meaning your memory will be saved, and it's much more efficient way in solving. And that's what mostly major programmers do. They try to make the use of your resources as efficient as possible without creating much memory, okay? Without consuming that much memory, because memory is critical and it's like a resource for all programmers. So you don't want to mess up with memory for no reason, right? So that was it with the referencing.